Welcome to Theo Laser.
Hi.
My name is Ryan Fahey.
Eric, how are you?
Nice to meet you.
Nice to meet you too. I'm really impressed with the facility. I came in here and it was, it doesn't look anything like you'd expect if you're going to be doing welding. You think of welding as a dirty operation and you come into a place that looks like a bank or a service center.
You definitely would not expect that coming in here.
Yeah.
We do appreciate it. This is our welcome area. First things first, we'll have you sign this waiver form.
Oh, okay. This is just sort of liability. We've been informed.
Yep.
Okay. All right. All right.
Appreciate that.
No problem.
So yeah, this is the welcome area. As you can see over here, we have our Theo MA1, which is our handheld laser welding system.
Okay.
That's our main product that we sell here at Theo.
Okay.
Along with the integrated wire feeder.
Okay. So you would use both all the time whenever you're doing laser welding?
It's optional. You don't need the wire feeder. You
Okay.
can fusion weld as well.
Okay. All right.
A lot of our customers do like the the filler wire additive to their process. So.
All right. And when you say fusion welder, you mean it's sort of like stick welding, or there's no additional outside source of metal?
No additional outside source of metal. It's purely the photons melting the metal and fusing it together.
Oh, okay. Very interesting.
Yep.
Now you've got a lot of equipment here. These are not welders, right?
No. So those are purely just CW laser sources.
Okay.
Ranging from 500 watts all the way up to 6,000. Typically integrated into cutting systems. For cutting.
So these would be the sources for a laser cutting
Correct.
bed, CNC type of device.
Exactly.
These are continuous wave, they're not pulsed, and you would never use these particular sources for the welding.
Handheld welding.
Handheld welding.
Yep.
Okay. All right, that's cool. Now, it seems like this is not where you would do any kind of like actual laser work. I mean, this is not just a business office, right?
So it is a business office, but we do have our Theo Academy lab.
Okay.
Our application specialist will take you through all the details and process of actually getting to weld.
So you mean not only would I decide that I like the Porsche or I like the Ferrari, I would also be able to learn how to drive it?
Exactly.
Wow. Okay. Well, lead on.
Let's get to it.
All right.
This is our office side. As you can see, we got our Theo Academy sign right here as well.
So you know where you're at.
Yep, kind of directing us to the location.
Wow.
Yeah.
So where are we going?
So right down this hallway. Right down this hallway here. And then right inside this room.
So you got the laser safety signs for these two rooms,
Yep.
and then heavy doors like this.
Exactly. So whenever we have an active laser in use, that sign will be on.
And is the door then locked?
Yes, the door is locked.
Okay.
We have safety interlocks on the doors as well, so if the door opens, the laser will, turn off.
Okay, not just warn you or beep or...
No, it'll roughly shut off. Yeah.
Okay, that's a very good thing to do. Wow, okay, well, lead on. Wow. Yeah.
This is one of our CW laser sources. I believe a 3,000 watt X
Yep.
series.
Yep.
So yeah, we have the bottom cover open, exposing the fiber spindle here.
Now, when this says 3,000 watts, that means 3,000 watts of laser output,
Output power.
not how much power it's drawing from the wall.
Correct.
These are efficient, but it's still going to be more.
Right, yeah, so it takes 380 volt, three-phase power. I think the full load current for this unit might be 30 amps, if I'm not mistaken. So,
Yeah.
it's going to be a little bit more power draw than, your 3,000 watt output.
Right. Now, we have a couple of 1,500 watt, similar designs, similar models. And we selected them simply because the 1500 watts will run on single phase power, 220 volt single phase.
Yep.
Anything beyond there, you just need more power than single phase is practically able to deliver.
Correct.
But otherwise, it should operate pretty much the same principles.
In theory, yeah, it operates the exact same. So some of the higher power lasers are going to have a thicker fiber core.
Okay.
And other variances like that, more laser diode pumps.
Okay. So what actually is happening here? Electricity comes in from the grid, feeds into here. Where's it going?
So yeah, electricity comes in from your grid. We have a switching power supply internal to the unit. That then diverts the power to the drive boards. And the drive boards accept the logic from the control board to send it to the individual laser diode pumps.
So laser diode pumps, meaning this is not a diode laser. This is a fiber laser.
Correct.
But where do the diodes come in?
So the diodes, that's what is used to convert the electrical energy into light.
Okay.
And then that light is then pumped into the ytterbium doped fiber laser.
Okay, so the diodes are the first stage in converting electricity into the final output that comes out of your yellow delivery fiber.
Exactly.
And so the diodes are the ones being driven by all that wall current.
Yep.
But the fiber laser is being driven by the light from the diodes.
Exactly.
Okay, all right. Now, when you say fiber laser, you don't mean fiber delivery, you mean fiber generation of light.
Correct.
Okay.
So when the light is pumped into the fiber optic line, it's a ytterbium doped fiber laser, so a rare earth ion. Those atoms are excited and then amplify that light into photons as it's traveling through the fiber line.
Okay, and because of the process, the diodes always have to have a little bit more energy in their light, so they're a little bit shorter wavelength, a little bit bluer wavelength, even though you can't see it.
Yeah, exactly. So we call that residual wavelength.
Okay.
So the output, for this one, I'm not exactly sure. It might be in the 1080 to 1100 nanometer wavelength range.
Right.
For the diode pumps, it's right around 1,000. Might be
Okay.
less.
So there's that little bit of deficit or whatever that is in efficiency, but it is the best way to pump the fiber.
Exactly.
Because they're so efficient. Diodes are just so efficient. So how many diodes would be in here that you can't actually see unless you kind of really...
So they actually work in pairs. So
Okay.
I think on this one there's 6 individual pumps. But
Okay.
again, they work in pairs, so our logic and our software count them as 3 pumps.
Okay. So 6 diode laser pumps are producing all of the light necessary to make that tiny fiber produce fiber output.
Exactly.
Is this the fiber that I'm seeing up here?
This is the exact fiber optic line right here.
So that tiny, hair thin, I mean, it's close to a human hair.
Yeah, the actual core is right around 50 microns.
So a 20th of a millimeter in diameter. And you have 3,000 watts coming out of it.
It's impressive.
But a laser is a resonant cavity. So the light intensity in this fiber is actually higher than 3,000 watts.
Exactly. So, as it's traveling through the fiber line, it's going to be exiting the fiber output.
Yeah.
And that's where you're really generating, the focal point. So, for example, on our handheld laser welders, our spot size is 20 microns.
Wow. And that's done with lenses, obviously, post fiber.
Yep.
Now, obviously, you need cooling for this.
Mm-hmm.
The diodes that are pumping it are consuming a lot of power. They need cooling.
Yep.
Does this need cooling? The fiber itself?
So it does get warm, but that's not the main, function of the cooling circuit. Like you said, the pumps, those are, getting really hot. Each one has a heat sink underneath it.
Okay.
Some thermal paste. This does use water cooling.
Right.
So roughly, 20 liters per minute. The water lines, you can't see them, but they're underneath the fiber. There's like a cooling chamber underneath here. And then on the other side of that, that's where the pumps are.
So the plate stays cooler than it would if it was just inside of a box.
Exactly.
Okay. And does the fiber itself become warm? Like if you touch that while it's operating, would you feel any warmth on the fiber? The delivery fiber?
Yes. So I don't think this one does, but some of this one does. So there is a water line on the output heads as well.
Okay.
So those accepts 2 to 3 liters per minute
Okay.
of water.
Now, those are the two water input lines that provide cooling flow
Input and output, so one's input, one's output.
for the head.
Correct.
But is water traveling through here?
No.
Okay.
No, so not through the line itself.
So it's the exit of the light coming from the fiber.
Correct.
That can generate heat in the lenses and...
Yeah, so
Okay.
like for example, if you had any sort of contamination on your collimating lens or your focus lens and light starts to bounce back up, that's going to significantly heat up the QDH or the fiber output.
Okay, very good. And obviously, if anything got dirty on the output, you'd be in big trouble because it would burn the dirt and
Yes.
destroy the lens or anything.
Exactly.
Okay. Lastly, this thing seems quite light. I mean, compared to what I would have thought of for that kind of amount of power. What does this weigh? This is a 3,000 watt unit and...
So this one, a fully built up unit, I think it would weigh around 40 to 50 kilograms.
That's not bad. That's not bad.
So this one actually does have the power supply taken out of it, so that's why it does weigh a little bit less
I see.
than what it would.
Okay.
Still though, it's not, it's not extremely heavy. It's definitely maneuverable.
How high do they go in terms of power before the form factor changes? Like you get a different style box? Or...
Yeah, so this is actually our newer generation of the X series.
Right.
The previous one was a little bit larger. Once you start getting up to the 6,000 and above,
yeah,
that's when you start to get a different design.
Okay. They sometimes call them multi-module.
Correct.
Does it mean it has several of these inside of it?
Correct.
Okay.
So, technically, this is a rack. This can be a rack-mounted
Yeah.
laser source. Some of the 6,000, 12,000 watt series are MFMC, which is a multi-module laser source.
Okay.
So it will have, 1, 2, maybe 3 optical modules,
Yeah.
coupled with an electrical module for the logic and power.
And is this robust enough in terms of its like sealant and its vibration that you could put this in a rack and have this in a regular factory environment, or do you have to have like a special room just for the laser?
No, this definitely can be mounted onto your cutting system.
Okay.
If it does have a rack available for that,
Okay.
that should be no issue at all.
And finally, this is the continuous wave source. Is this pretty much the same principle and just in a different kind of package with the welding application?
The theory behind it is the exact same.
Okay.
So obviously with the handheld welder, it's going to be a little bit more condensed in terms of the power and the internals and the design and whatnot.
Okay.
But the way that the light is generated is the exact same.
Hi, John.
Hey, I'm John.
Hi, Eric.
Eric, good
Nice
to meet you. I head up sales here.
They told me to come over here because you can give me a little bit of an insight as to how to get started with this
Yeah,
process.
definitely. We'll take a seat. So preemptively, I told you before anyone comes in, we send them to our website and we
Okay.
have them take an online safety course.
Okay.
That way, it gives them a little bit of background information on how to operate the machine safely. We're not going to skip anything here, but it gives them just a good 30,000 foot view,
Okay.
and then it familiarizes most people with the machine as well. So.
And you can find that basically just...
Correct.
Theo.
Yeah, just Theo.inc, and then there's a header, Theo Academy. So just
Okay.
click that, and
All right, very good. So what do I need to know? Like, I've welded a couple of times in, the past, oxyacetylene sort of thing, but no real skills in welding. Is that going to be a problem?
no, it's not at all. To be honest with you, sometimes people with zero welding experience pick up the technology a lot quicker than someone who has welding experience, because there's some certain things that you almost have to unlearn.
Okay, all right. So what do I need to know to sort of be able to use this?
Yeah. So I think obviously, we covered the safety stuff. That's the most important. Theo is very, very keen on safety. But other than that, I think you need to understand who we are, what we do. Obviously, we're a wholly owned subsidiary of Max Photonics, which is the most innovative laser company in the world. So that's a real important part of the presentation. But other than that, I like to walk through some differentiators as to why our laser welder is the best on the market. We'll cover everything from gun size to touch screen, spot size, which again goes back to why it's so important that we are Max. And then a few other things, like we feel we have the best wire feeder on the market, in addition to the service and support, which I believe you've already met those gentlemen today. But
Right.
we pride ourselves on having, world-class service and support. I know some of the other organizations kind of fall short in that area. So in addition to safety, we really, we lead with service and support.
How long has your footprint been here? We were very impressed with the building. We're very impressed with the laboratory that I got a chance to take a look at. Is this been here for a week or 20 years or just?
Yeah, so Theo was launched at FabTech 2023.
Okay.
So I believe that was in Chicago, September.
Okay.
And the brand was launched September 2023. The facility opened up in May 2024. And I think we took our first training group into the Theo Academy lab in June of 2024. So we're talking like 9 months, so still under a year. It's still a new facility.
And this is one facility. You have locations that are not just outside of Boston.
Globally, correct.
Right.
Domestically, this is the sole headquarters. We don't have any other facilities yet. I know that's been discussed as we grow our footprint.
I see.
And we onboard more and more customers and distributors and end users. I believe we'll open something closer to the West Coast because that's a big market for us.
Okay.
But right now, this is the only Theo location.
So when you talk globally, do you mean just China and the United States, or do you mean Europe? Or?
Oh yeah, we've got a huge footprint in Europe, South America.
Oh.
We just opened an office up in Australia, New Zealand.
Oh.
So we are truly a global brand.
Oh, okay, cool. All right, let me shut up and learn something here.
Yeah.
So what basically would I need to know to be able to get started, other than just read a manual and say plug it in and turn it on? What are the first outside of the laser requirements that I would need? Like, for example, I need safety equipment.
Yeah, definitely safety. And then there's some ins and outs of learning how to get familiar with the gun. Mm-hmm. Obviously the gun is going to be the point of which where the laser comes out. So making sure you're able to optimize the gun. There are some few different specifics. For example, if you're using aluminum, you set the gun up differently than with stainless. There's different tips. There's actually
tips. You mean not like hints? You mean like gun
yeah,
tips?
like a
Okay.
contact tip.
Okay.
Can just skip a few slides here. So we got right here. This is the tip of the gun. There's I think 5 or 6 different tips.
Okay.
That can be twisted on the end of the barrel.
Okay.
Based on the application that you're doing. So.
Okay, and so what I'm seeing there, just if I look at the screen, it looks like you've got a very, very thin piece of wire that's sticking in front of the end of the barrel of your gun.
Correct.
And that's being hit by the laser beam itself?
Correct.
Or
Exactly.
is the laser beam hitting the parts to be welded?
Yeah. So right here, the fiber runs up to the kind of elbow of the gun, and then it hits a mirror. Mm-hmm. You can actually optimize how wide that mirror splits. So if you are using wire, you want to make sure that it doesn't overlap too much because it can actually impact what the weld looks like.
Now that's, forgive me if I interrupt, but I'm really excited about this. You say there's a mirror inside of the
galvanometer,
itself
correct.
that is actually scanning the beam. It's not just a hot beam like from a magnifying glass burning the sun. It's actually moving back and forth.
Correct.
Why does it do that?
So that actually simulates what in traditional welding would be referred to as a weave pattern.
Ah.
So the way it works is, again, the laser comes up the fiber, it hits this galvanometer, and then it can actually widen it as wide as 4 millimeters, or you can set it to 0 where it is.
Just a point.
Correct.
I see. Okay.
And obviously the wider that it goes, the depth gets degraded. So if the mirror is scanning in like a triangular pattern, it's not going to go as deep as if you were to set the wobble, we call it wobble. If you set the wobble to 0, it's just going to be a fine laser point.
So that's another setting that you would have beside wire diameters and
Correct.
rates
Wobble.
and wobble.
So you can set up the wobble width and you can set up the wobble speed.
Is this going like thousands of times per second or twice a second?
Oh no, it's thousands of times per second.
Okay.
I think the maximum it's measured in hertz. So I think it's like 240 hertz.
Okay, so it's pretty fast.
Correct.
Yeah, you can't see it even if you could.
If you slow it down to like 20 hertz, say, and then you actually run the laser on a piece of metal without the wire, you can actually see the pattern zigging and zagging back and forth. It's actually one of the things that I like to do to kind of demonstrate that feature in a demo.
Cool. Okay, so what other things about the laser might be different than I might see if I'm doing TIG or MIG or, you know, some other kind of stick welding or whatever?
So this machine specifically is a touchscreen. So, you know, a lot of the traditional welding machines are just knobs and levers.
Right.
And some of the laser welding machines today actually have knobs and levers too. So we actually made it a lot easier for the end user to use. You just plug in, okay, I'm doing this specific alloy, this is the thickness, and this is the type of welding that I'm gonna be doing. So is it a butt weld, is it an outside corner, inside corner? And you put those three inputs into the touchscreen, and that dictates the strength and the type of laser that actually comes out of the machine. So we eliminated all the guesswork.
Is what's doing what normally you would have on the side of a welder where you've got this great big, you know, clipped on list of diameters and you're trying to set all your buttons.
Everything is automated,
Okay.
yep. We make it super easy for the end user.
Cool. Okay, great. What about the power level? Is this going to be very, very slow compared to traditional welding?
Oh, no. So I think our marketing says 4 times faster than TIG, but I've actually worked with customers that have turned you know, a 1 hour long application into an 8-minute application. So that's what, almost 8 times faster. I think we've talked to folks that have said 10 times faster, but to make sure we don't overpromise and underdeliver, our marketing says, you know, 4 times faster than TIG.
Just maybe the logic I'm struggling with, because the unit that you showed me briefly in the laboratory before I came in here said 1,500. Like
1,500 watts.
A typical, like, you know, TIG welder is going to use more power than that, but it's slower. Where does all this additional efficiency come from?
Yeah, so you got to think about it. It's a completely different heat source, and it's a lot finer of a heat source.
Oh, okay.
So our laser beam is 20 microns, which is half the width of a human hair.
Oh, okay.
So think about like a pressure washer, right? The finer the point, the deeper the clean, if you will.
Makes a lot of sense. Okay.
So our laser beam is the smallest in the market, that 20 micron spot size. And again, that's another benefit of us being Max Photonics. We're always innovating. I think we have over 550 laser patents.
Oh, wow.
So we'll always have the most cutting edge laser technology inside our laser tools. And, you know, specific to this product line, the spot size.
What about the heat affected zone? Because you are concentrating the light down to a very small spot.
Correct.
This great big glowing pool. Do you still get good penetration of the heat in there, or better or worse? Or?
It's much better, and there's a lot less heat distortion.
Oh. Okay.
And it also, the heat dissipates a lot faster. So traditionally, if you want to get, you know, a fully penetrated weld, you got to slam a bunch of heat into it. And what will end up happening is, you know, the rest of the heat will go throughout the workpiece, and you'll get almost what looks like a potato chip, like a Pringle.
Yeah.
So there's a lot of, you know, bending and heat distortion.
That makes a lot of sense.
Yeah, that's virtually, it doesn't exist.
And that goes across all materials, whether you're using aluminum, steel, stainless, doesn't matter.
Correct.
That same benefit applies.
Correct. Yeah. Now, if you go this, you know, if you go multiple passes on the same weld, you're going to be putting more heat in, so you may see more distortion. But you know, if you really perfect the fit up and do a proper, you know, approach angle and then the proper drag speed, you should be able to get the weld in a single pass.
Okay. And then also for a person who's not welded, I don't come in with any contaminated idea of what the dimes should look like.
Exactly, yeah. Like I said, sometimes like just like someone who's like a smart, you know, able-bodied person is a lot quicker to pick up laser welding than someone who's welded. Exactly, right?
Okay, got it. Okay, that sounds pretty cool. Anything too that I should know about before you bring me into the lab and kind of we start to do this? Things that I should watch out for that are typical questions or problems that often come up later on, something you should have thought about in the beginning?
Yeah, don't drop the gun.
Okay.
You'd be surprised how many people, and these guns are, you know.
$20, $30 each?
No, I think it's less than 1,000, but they're not cheap.
Okay.
But every single laser that we sell actually comes with a pretty fancy holster to hold the gun on the table. And what I recommend is if you're going to buy one of these laser welders, that you set up some sort of hanging apparatus from the ceiling so that it's impossible to drop the gun. You know, when you're done using it, you can put it in the holster, but it's being hung from the ceiling so that it can't physically hit the ground. Or sometimes I've actually seen the laser fiber get run over by a forklift or something else in the shop. So we like to avoid that too.
Obviously, would destroy almost anything. But like, say, if I accidentally stepped on the fiber cable,
it shouldn't damage it. I mean, unless you repeatedly stepped on it or danced on it, did something like that.
Okay, so it's not that fragile, but obviously.
Don't try not to step on it.
Okay, I'll do that.
Thanks. Yep. So this is our lab. This is Harrison, our application specialist.
Hi,
Nice to meet you.
Nice to meet you. Thank you very much. Appreciate all the help so
Not a
far.
problem.
All right, I'm ready to go to school.
All right, well, you're in the right place. This is Theo Academy. This is where I have our handheld laser welding lab set up. You can also see we have live streaming abilities, so I can do virtual training and demos.
So that thing right now is showing this.
Correct,
Got it.
correct. So that's really what people want to see. They want to see their parts getting welded, how fast I can do it, how consistent it is.
Okay.
And that's what I'm here for. That's what I'm going to show you how to do today.
Okay. I don't know anything about laser welding other than theory, so start me from the beginning.
Well, it actually exists.
Okay.
We do this here. I personally have been laser welding for about 4 years. Started off with one of our competitors, came over here. It can be done extremely safely, but there are 3 tenets. First of all, environmental safety.
Okay.
Number 2, personal safety with the right PPE and the infrared safe eyewear, masks. And thirdly is understanding how that light can melt metal,
Okay.
but how to stop it from melting anything that you care about, including the machine itself.
Okay.
And before you leave here today, I want you to feel confident that you know what you're doing.
Okay, very good. All right, so what's first?
First is, in order to make this a laser-safe enclosure, I need to enclose it. So I'm going to do that right now.
Now, when you say enclosed space, like for example, if we had bought one of these things and we set it up in our shop or our factory or our home shop, doesn't matter. If we set this up, we would need to have some of this additional equipment that goes beyond just the laser itself and a closed door.
You need to make your workspace light tight.
Okay.
You need to enclose that class 4 laser because the human eye has no idea what that laser light is. It has no natural defense to it.
Okay.
So you have to worry not so much about your immediate surroundings. Obviously, any sort of handwork, hot work, you need to have situational awareness.
Okay.
But there are so many variables, and you're dealing with a beam of light half the width of one human hair. So it's very difficult to be welding on an island or an open field and know that you're going to contain that. It's just very difficult.
Because if you're on an island, you've got 4 sides that the light can go anywhere.
Correct.
Okay.
Correct.
So this is to take care of the sides that aren't already walls.
Absolutely.
Okay.
Absolutely. Yeah, I had to block off all the windows on that wall. Not so much concern in this room, but even if you are putting this in a facility that has a catwalk or a suspended office where people could look down into it, you would have to cover that up too.
Okay. So any way that somebody who doesn't know what's going on could inadvertently pass near you, they can't see you.
Right.
Okay.
Right. Light tight.
Light tight.
Light tight.
Okay, I'm good.
All right.
Okay, got it. So I'm gonna come in here then.
Okay.
Yes.
I was actually going to suggest do a little cool segue and say light tight and actually close it in front of you, but we don't need to do that.
Nah,
Okay, that's just corny.
Okay.
It is corny.
It is corny, but you know,
We do the corny
sometimes.
So actually, at this point, what I normally do is a panel overview for this
Okay.
machine. All right. So I'll actually, in the interest of where that is,
Yeah.
I'm going to switch this around. I'm going to start with the back first, so you see the inputs.
All right.
All right. Let me know if it's in frame. I'm sort of limited with my.
Yeah, I can do it.
Okay.
So all the cable connections you're looking at, right?
Yeah, every feature back here.
Got it.
Okay.
I'm good.
All right. So this is a air-cooled fiber laser. So it's set up almost like you'd find in a gaming PC or a big tower PC.
It actually looks like it.
Correct. Yeah. It's 3 cooling fans up top, 3 on bottom. They're constantly spinning when this machine is on. That's not just to keep the optics cool, it's about keeping the humidity out of there, because that can wreak some havoc on optics as well. To continue on with the preface of comparing this to a PC, a lot of the same connections that you might have seen back in the day. So you'll have this multi-pin input here. 99% of our customers just use this for our door interlock switches.
What do you mean door interlock switches?
So in order to completely make the enclosure safe and also to adhere with the latest, can't really call them mandates, but standards, you have to have doorway interlock switches on any entranceways. So I have these daisy chains, so theoretically I can have all 3 weld cells go together without risk of anybody getting a laser flash.
So what happens if somebody just came in here and gave us a sandwich? What would happen? The laser break?
It wouldn't break, it would break your weld and it might irritate you, but it's going to keep that person with the sandwich from getting any eye or skin damage.
Literally will turn the laser off.
Within milliseconds.
Okay.
Yes, it will shut down the laser. The machine stays on,
Right.
but in order to adhere to federal law, at that point you would actually have to take your tool off your workpiece as a reset and then do another trigger cycle in order to get going. Next thing is, this is actually our least used port. This is our service port. So if our customers are having any real problems and it's not an obvious thing, they didn't try to take this fishing or have it fall off the back of a truck or something like that, we can flash the firmware.
Okay.
7-pin connection. So it's sort of hidden under here right now, but this is our Theo brand wire feeder.
Okay.
So this draws both power and communication to the feeder, with the exception of the 3 buttons on top of the feeder, which are your normal power on, manual retract, manual feed. Everything else is controlled through the touchscreen UI in the front of this.
As long as we're talking about power, what kind of power requirements would you have to have available, line power, to run this setup?
So this is a pretty adaptable setup. I personally, when I designed this lab, I wanted it to be the latest standard, so I've got some L630 twist-ins.
Okay.
But really, anywhere between 208 to 250, this thing will run.
Okay.
If you already have a dryer plug set up, it'll take that.
Single phase.
Correct. Okay. Correct. Single phase. Continue on. So we have our electrical ground here. That's just your standard workstation ground.
Oh, I see. That's to the table.
Correct.
Okay.
Correct. And you can also have your 6mm OD PTC gas connection.
Okay.
So that's going to be your shielding gas. Now, one consideration with these handheld laser welders is to keep in mind that shielding gas isn't just protecting the weld, it's keeping your optics cool.
Oh, okay. So like the continuous wave laser that we saw before.
Correct.
The source, which was using water cooling, it also had a little bit of a branch that water cooled the optics, not just the source.
Right.
Same thing here,
Right.
air
Yeah.
or gas.
Yes, shielding gas, shielding gas. So our machine was built smart enough, if you don't have enough gas flow, it's going to error out right off the jump.
Okay. All right.
There are a lot of safeguards in this machine to keep it from eating itself. Other than that, you have your typical on-off switch here. And if I flip this around to the front, I can show you the front panel. So customers that have been looking at a lot of handheld laser welders, they've pretty much seen this before, with the exception of our UI. I'm excited to show that to you, but
Okay.
without this, this does nothing. This is your sort of Achilles heel of this machine in terms of if you don't have this interlock clamped to your workpiece or workstation, this will not let you do anything.
Even though you've got the ground in the back, that's not sufficient. That also has to be
Yes,
grounded on.
yes, and that's federal law. We had to do that.
I see, okay.
Okay, and a couple other things, federal law, we had to put this manual e-stop button on there, and I can tell you after 4 years of using these tools, if you ever find yourself in a situation where you need to use that, I wish you all the luck in the world finding it. And I don't want to hear about how it happened, especially if you came through here.
But it's in there and it does work.
It's in there. And you can also, through that X control cable back, you can add a second one for whatever reason you might want to.
Right.
Finally, you have this on-off mechanical key. It does work. It was the law, we had to have it on there, but as an insider tip, if you ever want to secure one of these machines so you don't have to worry about anybody doing anything wrong, just lock this up. You can see that's perforated on one end.
Oh, I see, okay.
The other end is a very
Got it.
fine tooth alligator clip.
clever.
They're gonna have a hard time finding one of these.
Okay. So even though you have a key and you have sort of a kill line, something that will stop it.
Right.
You also have the on-off switch in the back. So you have to turn it on and the key and that.
Yes,
Okay.
yes. Generally, because I control this lab, that door is locked when I'm not in here. It's locked when I am in here too. But yeah, I don't worry about leaving this in. If I am worried about it, if I have sales guys doing a little too much sniffing around, then I'll take this out.
Fair enough. Okay.
So with that said, my first rule of thumb to keep everybody safe along any sort of class 4 laser, I would love to turn this on for you, but first I'm going to need you to put those laser safety glasses on.
Okay, for now, real. Okay. So any one of these?
Either one of them.
Now, don't these things come with some sort of indicator on them that they're adequate
Absolutely.
for this laser?
Absolutely. So you'll see on the top of these glasses, you'll have your wavelength and OD ratings clearly stamped. So for this machine, we run on 1080 wavelength. We require minimum of OD6, and I believe here you'll see these are actually OD7 up to 1090.
And OD is optical density, which means the power of 10 reduction.
Correct.
So OD6 is 1 part in a million can get through.
Correct.
Okay. All right.
Makes sense. You can add that.
Okay. Now I'm legal.
Almost.
Now I'm legal.
Yeah, whenever you're ready.
So if you're ready to go, I'm going to go ahead and flip the switch. I'm also going to crack my nitrogen because, like I said, this thing will start beeping right off the bat if it doesn't have enough flow.
Now, just as long as you're mentioning that, you said you cracked the nitrogen. This is running on pure nitrogen gas as the shielding gas?
Correct. UHP. UHP.
Now, why is that? Because, I mean, in certain instances you use carbon dioxide and argon, and then there's nitrogen. It's like, why the gas choice?
Now, to be fair, we do recommend argon for aluminum.
Okay.
Okay? Everything else you can get away with nitrogen.
Okay.
And if we have our customers who are saying, hey, we're already using argon, then that's fine because it's a heavier inert gas.
Okay.
When it comes to CO2, there are a few reasons why I wouldn't recommend it. Number one, I've had zero luck with it in my own R&D applications.
Okay.
Number two, you have such a small aperture for gas protection that really, if you're not blowing inert gas, if you're not blowing something that will keep the oxygen out and provide a nice heavy blanket of nothingness, then you're going to wind up with porosity in the wheel.
You want some weight to the gas because otherwise with the Venturi effect, you're going to be drawing some room air into any kind of flow.
Correct, correct.
That makes sense.
And the opposite is true too. If you put too much gas out this tube, you can actually blow your work right out of the joint.
Oh, because it's liquid at some point.
Correct,
Right.
correct. So this thing went through its first, self-check upon cold start. You can see up here, all 3 fans are spinning.
Now, when you said cold start, we didn't cheat. This
Correct.
was cold from this morning, so
Correct.
this is the normal interval.
Haven't started it at all today. Yep. And it doesn't matter, even if you shut it off for 10 minutes, come back, it still has to go through its self-checkup. you know.
Okay.
It's very computerized. So you'll see we have this touchscreen UI going through these precautions, just the very standard "don't sue us, we warned you" type stuff.
I like that.
And so I'm gonna say something real here for anybody watching this. You'll see your alloy selections up here. You'll see stainless, carbon steel, galvanized steel, aluminum. That being said, everything else on this basic menu gets 90% of our customers what they want right out of the box.
Without doing any more research on wire diameters and feed rates?
Correct.
Okay.
So what I will say as an aside, we do have a selection of wire tips and other accessories that come in the box. I can tell you from my example, I will only use this style tip. So this one is tip A, that's for thinner gauge fillers.
Would you be able to bring that over?
Absolutely.
You want to actually show them the whole selection and then point to the one that, as you were showing me, show the camera.
Okay. I actually threw away the forked ones because they're useless.
Okay.
So I'll put these in though. So your MA1 will ship with an assortment.
If you'd be able to bring it towards the camera.
Okay, yeah. I mean, there's really not a ton of variety here. But your Theo MA1, they do ship with an assortment of tips. In my experience, these are really the only two tips that matter. So you have tip A for wire diameters up to 0.35. And then tip B for the wire diameters above that. This thing can take up to roughly 0.62 wire.
Okay, and the only thing about the tip that I noticed that isn't just a cone is that it has a little bit of an angle, a bevel.
Correct.
At the opening end.
Correct. So that's for two reasons. Number one, so you can see the guide beam more easily when you are aligning the tool.
Okay.
And number two, that just works a little better, not having way too much turbulence from the shielding gas come out, just because it is so small.
Got it.
And you will have an assortment also of your wire assist tips, but really, in the interest of doing these general demos, I stick to 1.2 and tip B for 0.45 wire.
Okay.
Our machines, all of the factory presets for wire assist were developed for 1.2, the global measurement. So I recommend 0.45 for steels, 0.47.
Okay, and just as a guideline to somebody who's not a heavy-duty welder, these narrower diameter openings are to guide the wire into the field.
Correct.
This is what's providing the shielding gas directionality.
Correct.
Around the work.
Absolutely.
Okay.
So
So
when-
you use two.
Yeah, so actually, if you don't mind, let me just grab that right quick, and I can show you. I'm gonna put the tip back on there.
Oh, the one you just took off?
Yeah,
Yeah.
that's okay.
It happens.
Yep. So this is pretty much what you want to see if you would like to use a wire assist application with this. You want to see the notch. You want to see that wire lined right up in that notch.
I see. So this beveled tip here actually has a notch in the bevel
Correct.
where the wire is actually kind of almost looks like it's cutting through the end of the bevel.
Right.
Okay.
And then here's where being a little OCD helps, is it's a matter of getting that guide beam exactly centered on that wire.
Okay.
So when we actually get to weld, I'm going to tweak this a little bit more, but this is pretty much what you want to see. And if you were going to weld with that,
Can you rotate a little bit?
yeah, I want to show you this. That's your stick out.
Okay.
That's how you're going to approach your joint.
So the aiming beam should pretty much be at the terminal end of the wire.
Correct.
When you're ready to start.
Correct. Because at the end of the day, it's still the laser doing the work. You're
Right.
literally just your auto cold feeding MIG wire.
Got it.
So, So with that said, I'm going to demonstrate fusion tacking and a wire assist final weld for you.
Okay.
I'm going to answer whatever questions you may have, talk through this as I'm doing it.
Okay.
If you need me to stop me.
Okay.
Otherwise, I'm going to do one, and then I'm going to pass you the torch, talk you through it.
Okay, sounds good.
All right. So let me get this out of the way. And
I'm gonna move a little bit closer.
I don't know.
Okay, tell
Yeah.
us when you're happy and then we'll start. No, I'm happy already. So these gloves?
these are just regular TIG gloves.
Okay.
All right, you don't need anything super special here. It's mostly, if you're using this tool properly, you're always going to be behind the gun anyway. Okay, it's mainly about keeping your skin safe.
Yeah, because your hand is relatively close to the field, even if you're in the right
Correct.
position.
And with that said, it's a much smaller heat affected zone, so you don't have to worry so much about radiant heat, but sometimes spatter can still happen with galvanized, that sort of thing. And,
Okay.
you know, it's just cover yourself up. You do still have some UV light from the molten metal pool.
Okay, it's hot enough, it's actually glowing on its own, not laser light, but ultraviolet.
Right. But again, it's the laser light that you really need to worry about.
Okay. Now, you're wearing protective eyewear
And-
below this.
Correct.
But this also filters.
Correct.
Okay.
This,
Am I okay with just
yeah,
this?
I'm gonna ask if you wanna get closer, stay behind that yellow line. So, like I said, you want light type fits whenever possible with laser welding. You're going to be able to see what I'm doing a little bit better on there, but if you want to get way over here, I'm going to ask that you drop your mask as
Okay.
I tack this.
All right.
I'm just going to line up my tool. Since I'm welding a 90-degree joint, I'm going to bring the tool in at a 45-degree angle. And when I'm lining up with that guide beam, I can use that red guide beam that's just like you would find in a typical laser pointer. And that's going to help me ensure that I'm nice and centered on that joint. So
Is
I'm
there
gonna-
any wobble going on in the handpiece
So-
with that point too?
that's what you see here. So if I pull the gun up, that's a dot, right?
Yeah.
Then I touch it, that's a line.
Got it. Okay.
So that wobble is constantly going as long as your tool is on and you're touching this to an interlock surface.
Okay.
Yeah. So I'm going to put my first tack in on this. I'm doing this over a channel because there's no way to stop a beam of light once it's out the tool, and I don't want to have to chip this thing off.
Okay.
I'm going to pull this about 1/8 of an inch back from the end of that joint. Just give it a little tack here. All right, now I'm going to flip this around and do the same thing. I'm always going to make sure my hands and face are behind the tool.
That buzzing that we hear.
That's tack penetration. But what you're hearing right there, that's actually the tiniest gap that actually got sucked down as I was tacking it.
Okay.
So that buzz is the hertz. That buzz is that wobble.
Okay.
And you can actually hear that light hit the metal and start melting it.
Kind of like with a laser cleaner where you hear that buzz.
Correct.
It's not being pulsed, it's being moved.
Correct, yes.
Okay.
Yeah. Now with that being said, for a standard demo, start moving over to the wire assist. Wire assist welding on this tool is actually easier than fusion welding because you don't need to worry about your travel speed, okay? It's the wire feed speed that sets your travel. The wire will actually be pushing you back. So again, yeah, that's the only way you're gonna travel with this.
So you'll actually feel the pistol or the gun.
Correct.
You'll actually feel it wanting to move you in the direction you need to move.
Correct, and you better just get out of its way too. Otherwise, you're gonna wind up with some OP and potentially an angry machine, but we won't even think that way here. So I give myself a nice little guide beam at the end, proper stick out.
Okay.
I'm going to use my body weight, and since I'm right-handed, I'm going to put my body weight on my left hand. And in the interest of safety, I'm going to kick on this extractor. So again, like any other welding, good rule of thumb, do a dry run. Make sure you're going to be comfortable. On top of that, you do have that guide beam, so there's no more guessing as to whether or not I'm actually going to complete that joint. I can see it. I can see it up there. I can see that guide beam going over that wire on both sides. So at this point, I'm going to make myself comfortable. I'm going to start at the end of that joint. You're going to see me pull the trigger. You're going to see me dwell for about half a second. And I'm going to watch that filler cool up onto both of these plates. And then I let it push me back. And you're also going to see my face stays behind it the whole time.
When you finish it,
Yes.
just finish it. No pause at the end, no dwell at the end.
Don't pause at the end. Now, your first one, you might have a bit of a wire stick. That's normal. You may not. You may intuitively know that when you get to the end, it's not a matter of just releasing the trigger. Give a little flick of the wrist and let the laser break that wire right at the end. So I'm going to leave it up to you, sir. I'm going to give you the option. You can either fusion tack one of your own, or you can put a wire weld down on the other side of
Let me
this.
try the wire weld.
Okay.
I'm also left-handed, so I would probably stand the same way that you did. And I like this specific one.
Well, if you're if you're left-handed, you might want to do the,
Opposite, right?
yeah, you might want to mirror that.
So you were doing that just for the camera, even though that was your...
Well, I'm right-handed.
Oh, I thought you said you were left-handed.
Did I say I was left-handed?
No, you didn't.
Okay.
No, I got it wrong.
All right.
I'm almost positive you said, since you're right-handed,
Yeah.
I put it on the left side or...
I haven't made that mistake before, but I wouldn't put it past myself on Friday.
How does this look like, I'm going to be very specific. My
Yeah.
gap position well over the middle of the gap?
Perfect.
Okay.
Perfect.
All right, and then, now if I look at this,
So you're going to need to, once again, make sure that that filler wire is in the notch. So I would raise my mask. You don't need that mask down until you're actually firing the beam. So it's not so much a matter of pushing. Sometimes you might need to tighten the threads on that just a bit. That looks good.
they were pretty good.
That looks good, so I'll snip that for you.
Just barely on the tip.
Very good.
Okay, good. Now,
So before you put your mask down, why don't you give yourself a dry run? Make sure you're going to be comfortable having that torch push you back. And I also want to make sure, looking at you over here, okay, you're definitely, so you're not weaving. You are not weaving. I see what you're doing with the wrist there. There's no reason to do that anymore. So just get that torch at a perfect 45 to meet that 90.
45 in this direction?
Yes.
And the torch itself will handle this angle, right?
Correct. So this is actually built for a reason. If you approach any joint, okay, if you keep your trigger surface parallel with your joint approach, this angle that was built into the torch
Got it.
is going to keep you naturally in line with where you want to be.
That's logical. Okay. So let me just try that even being against it. All right.
And let me know when you are ready to weld. I'll kick the extractor on for you.
All right, hang on one second. Oh, the part's a little bit warm. You can tell that there was some heat.
Oh yeah, well, I just got 5 inches of weld put on there.
Yeah, I think we're about as good as we're going to get at this stage in my career.
Alrighty, well, take it away.
All right.
And if I holler at you, it's going to be because I want you to move your head behind the gun.
Okay.
You always want to be able to see. You don't need to see what the indicator lights are doing. Just see that indicator panel.
Okay.
And that means your eyes aren't too far ahead of the torch.
Okay, I think I'm ready to give it a go.
All righty. Just let it push you back and make sure you're not going to bump into your own hip at the end too. You might want to take a step back with your left foot. There you go.
You're going to do the fume extractor? Or?
Yep, that's kicking on now. Whenever you're ready.
Yep, I'm ready. Everybody got goggles on?
Yes, sir.
All right.
There you go. Just let it push you back. Hey, you did it. You didn't even stick the wire. Nicely done.
Let's take a look.
All right.
No, this is better. Well,
Just a little bit.
I would hope so. Yeah, it would be bad if it was, now, let me just hold this up for you, Al. Okay. Now, I'm gonna be honest, this is his side.
Okay, pull it much closer.
Okay. This is his well.
Yeah, hold on. Give me a sec. All right, that's his well.
That's his well. This is mine, the first time I've ever tried this. You can see my angle got a little squirrely right there.
Could be worse.
But yes, it can be worse, but I have to tell you, I'm not bragging, but this looks pretty good.
Yeah.
And if it's like, that's the first time I've ever done this. And I really have never done this before.
Yeah.
This was not difficult to do.
Yeah.
And yes, I could definitely get better at this, but man, I would think after you did this 10 times, you'd be pretty competent.
I agree.
Okay. And then also something else I was just going to look at, if you don't mind. There's only a tiny bit of heat-affected warpage here, but it's pretty symmetrical too. So I think that is warpage. I don't think it was from these plates. Yeah. So you get a little bit of heat-affected warpage, but not much.
Well, you have to keep in mind too, that's 10 inches of weld on 80 thousandths material.
That's the point. This is super thin. It's not aluminum foil, but it's getting pretty thin. I'm impressed.
Appreciate that.
Wow. So now, this is basically, you call this an inside weld or the T-weld, but basically what it's designated there as a
Inner fillet.
inner fillet.
There,
Okay.
yeah. We can call it a T-joint here, but they
Okay.
call it inner fillet.
Okay, because it's on the inside of an angle.
Correct,
Okay.
correct. Now, you'll notice, at the end of the day, this thing is one of the fanciest flashlights you'll ever use, okay? It blasts a very precise beam of light. It controls it with the galvo. You control it to a certain point with your travel speed and keeping an angle.
Right.
But if you look at the different welding methods, so if I look at inner fillet, okay, and I'll just dial that in for a 1 to 2 millimeter carbon steel.
Right.
And then I come over to expert mode. So you'll see that's wobble width, 30% power, 60 hertz wobble frequency. All right. 60 hertz wobble frequency is pretty much a default no matter what you're doing until you get to the really, really thick stuff where having that slowed down makes sense. But that's what we had for inner fillet. Let's see if there is any difference. All right. For a lap joint, I'm just going to change that right quick and then go back to carbon steel, 1 to 2 millimeters. No difference, because at the end of the day, it's the same joint.
Right.
All right.
Okay. So you can have different ways to get to the same endpoint, but the machine is going to know
Correct.
how to get there.
And that's pretty much all laser tools.
Yeah.
Yeah.
Okay. Now that we saw, as you just described, that was 750 watts of applied light.
No,
That was
no,
50.
that one was actually a lot less. So let's go back to stainless 1 to 2 millimeter inner fillet, and then let's see what that dialed up. That was actually only 30.
Wow.
You don't need a lot of power to melt stainless with
That
these
was
machines.
450 watts?
Correct. Correct. I knew it was 450. I was about to say 500.
But that's 450 watts.
Correct.
That's the same as like a metal halide bulb in your
Correct.
shop.
I know. Well, a metal halide bulb in your shop is pretty long and wide. It's not squeezing all that power
Right,
into
but-
something that tiny.
But it's impressive
Yeah.
that it's just a matter of application. It's
Right.
not just raw power.
Right. Right. Well, raw power can turn this thing from a welder to a cutter,
Yeah, right.
and that's not what you want.
No, right, okay.
So that being said, if you want to see this thing throw a little more power, what I like to do in these demos is demonstrate how I can fusion weld aluminum in a way. I could make a fusion welded outside corner in a way that a lot of MIG and TIG guys right now would require so much post-processing afterwards.
Let's see that.
Let's see that. All right, so let's do this right quick. I'm going to choke the nitrogen. I'm going to crack my argon, and then under expert mode, I can purge the gas, and I can just keep an ear out.
I heard that.
Yeah. Now, somebody decided to help me out. All right, did you hear that start to beep?
Go on, because
All
there's
right.
no pressure.
Right, right.
Okay.
I could even crank that, so a little much. That should be fine. Let's see how that goes. I do it by sound, but for the most part, this machine is happy if you keep it between 25 and 40 cubic feet per hour for flow.
Okay.
So with that said, I got the argon over there, and I'm gonna prove to you guys. All right, I'm gonna take this wire liner completely off. I want to prove to you that I can do this with no filler.
In other words, that you're not cheating.
Correct.
Okay.
No movie magic here. All right. I'm going to take that off. I'm going to okay, so that's off. All right. That's off. And I'm going to go aluminum. I'm going to keep that at 1 to 2 millimeter. And even though I'm going to set up an outside corner, I'm actually going to call up for a butt welding parameter. All right, and you're going to see why pretty soon. So the first thing I'm going to do is just slide in here right quick, and I'm going to take a few of my aluminum coupons. I'll tell you what.
So we know that if we ever needed the contract welding work done, we just bring it down here.
I don't think Federico would appreciate that.
Yeah, he might.
You can take that home with you. So let me put this back.
Shows that he's much better than I am.
It's just something for you to think about on the drive back. But with that said, let me throw my gloves on. So that's warm, and I'm going to warn you, if you do want to try this, and I highly encourage you to try this after you see me do it, please don't touch it right off right afterwards, because aluminum does soak up heat a lot better than steel.
Okay.
Yeah. I only made that mistake with one customer, but I learned my lesson.
How many customers do you think you could handle here? Like, one a day, a group of 10 at a time?
So right now I try to keep a maximum of 4 to 6 people in here at a time, because after that I just can't give the person on the tool the attention they need. I have this lab set up for 3 different types of training, both online and in person. So we have a 90-minute general demo overview, kind of like what we're doing here.
Right.
If I have a customer who has a specific application in mind, a specific problem they're trying to solve,
Right.
I have a 3-hour session just with
Okay.
them, and then we just tackle that and that alone. And then finally, for our distributors and resellers and outside salespeople, I get super intense with them for 2 days.
To make them smart enough to be able to
Correct.
then transfer
Yeah.
information.
Yeah, if I need to see somebody can put together a decent T-joint in 2 days in order to sell this.
Right, without
Yeah.
all the help that I got.
Correct, correct. So with that said, again, we're looking at light tight fits.
What is that, like 8, 9 millimeter? What is that?
This?
Yeah.
Oh, this is actually just an outside corner fixture.
Oh, a
This,
fixture. Okay.
yeah, this is
We're
just a,
not- okay.
oh, no,
No,
you would
no.
never, you would never. All right.
We're building
I can
ships.
Put, yeah, I can put this on the record. You would never, with the handheld laser tools available right now, I don't care what brand you buy, please don't try melting that. You're gonna break it, all right? So with that said, all right. Again, light tight, that's what you want to see. There's your seam.
Yeah.
All right.
So the seam is on this side, not this side, so there's
Correct.
gonna be welding over there. Okay.
So I'm right-handed, so I'm actually going to approach it like this. And actually, if you want to take a look right now, you can start seeing the adjustments I'm going to have to do. So in order to really roll that corner, I'm going to have to stretch out that wobble. Because right now, if I tried shooting it, I'd either not
You'd
hardly
miss
get
one
it.
of them.
I'd either miss one of them, or I would have the ugliest, most scalloped edge up here, and I don't
Okay.
want that.
No
I want,
stacked dimes, just
right,
ugly.
right. You're not really going to be seeing stack of dimes here. It's not
Right.
what we do here, because we're not really melting heavy amounts of filler.
Right.
But with that said, I can make a nice smooth bead.
Okay.
So in order to help myself do that, I'm going to come back over here. I'm going to stretch that wobble width out. I'm actually going to stretch this out to 2.8 millimeters.
What were we at before?
2.0.
2.0.
2.0. 2.0 is pretty much the default for fusion welding with this. And because I am sort of fresh in the lab today, I'm going to keep that at 55. If I was good and warmed up, I could probably bump that up to maybe 63, just as a nominal, to make up for the reduced power density and penetration.
You're saying 63, 55% of 100, of 1,500 watts.
1500, yeah.
Okay.
Please don't ask me to do that division in my head.
No, and if you did, you'd need another job.
Yeah, you're right. Well, if I did, AI would have that job.
Yeah, right. That's true.
So again, if you want to stay there, you're going to have to flip the mast down, but even better, I would recommend that you stay back here. Because think of it,
good here. Yeah.
that far back, you should be okay. If you're worried, stay behind that smudge, and you'll for sure be safe.
The safety
I
slide.
don't
Yeah.
like why you know that, but
Well, listen, I would have to have done something so ignorant to send that light back to you. Because even at 55, even if you didn't have, I mean, you got your glasses on because that's the rules, okay? But even without a mask, if I were to somehow throw a perfect back reflection at you, okay? Back where you're at, it would have fanned out to the point where it would probably still be annoying, but it wouldn't hurt you per se.
Right.
got it.
If you're going to be that close, I would like you to stand at that corner.
Okay, I don't want
That's-
to be in the way of the cameras.
Right.
How about here?
That's
good.
fine. That's fine. I might be in your way just with this,
Okay.
but we'll see. I'm also, again, going to throw on the fume extractor because, as you'll see, one of the compromises to laser welding is additional particulates. You don't see spatter, you see smoke.
Okay. Yeah, that's interesting. I did notice a lack of spark.
Correct. Well, that's because the heat affected zone is so tiny.
Right.
There's really no more, yeah.
how are you sort of judging when you're kind of moving, maybe starting to go a little too fast, a little too slow?
So you can tell you're going too fast when you can actually hear it. When you can hear that laser chopping back and forth.
Okay.
Another indicator, let's see how I did here. Well, I actually did this. It's not perfect. Yeah, I got the, thank you. It's not perfect because I sort of shot the end there, but
Bring this a little closer.
So that's
good and
an
smooth.
amazing looking.
Up, right there, keep it there. Got it.
So you got a good and smooth face.
Looks very nice.
Thank you. And when I flip this around, you can see I did get full pen.
Yeah. Yeah.
Got it.
Now
Very nice.
you want to see how strong this really is. I don't have a full MATLAB over here, but you know, I got this thing.
So you,
I just smacked that right in the middle.
So basically, it's vented, but it's still together.
it's bending this, but the weld is still not cracked.
Yeah.
No defect.
And you didn't even let it go for that long, too.
Right.
Yeah, right. It's a little too hot to touch with your skin, but yeah, that's
Very good.
impressive.
So I got a question for you.
Go ahead.
You've been a student of mine for about half an hour now.
Yeah, I
Do
know.
you
I'm ready
think-
to train.
Do you think you can do one of those?
Oh, better than you can.
Well, let's see it.
All right. All right. Well, we got to start out with the ship part.
This out of your way.
I think.
And there's your other spring clamp when you're ready.
Oh, I see. You got a cheat here. The joint is okay.
So you might actually want to orient that the other way, just so if you're left-handed and you're gonna, yeah, there you go.
There you go. Okay. Actually, I'm having a problem here. I would normally be welding from this side. Don't I want the joint on this side, on the left?
Yeah, I mean, if you're a lefty and you like welding that way, then yeah.
I do. As long as mine-
You might actually be ambidextrous and not even know it.
Yeah, that was true when I was a kid. They pushed it, but I was a curmudgeon, so I probably am a left-hander. So line up the joint. This prep work is usually the whole secret. All right, that feels pretty good.
All right.
Okay.
And again, when you're ready to go, just give me a holler and I'll kick the extractor on for you.
And everybody's got the safety equipment on.
Yes, sir.
No changes in the parameters.
Nope, you're doing the exact same thing you just saw me do. Just make
Go
sure
ahead
you,
and turn on the extractor.
hold on. Just make sure your face stays behind that when you're ready to weld.
Yep. Any weld here?
So if you want, you could squeeze that and just give it a little tap.
Yeah. Okay. All right. Everybody ready?
Yes, sir. Alrighty. And now if you want to take a knee, I would highly recommend you get low, because if you stand over it, you're going to wind up leaning in front of it.
Okay.
There you go. And you're going to think I'm crazy. But if you're left-handed, I want you to put your right hand flat on the table.
Okay.
Slide it back. Keep going. So try tilting up the gun a little bit. good for your first one.
Only about half that.
Yeah. So you want to know what got you tripped up there a little bit?
Yeah, what was it?
You had the gun tilted back a little bit. So
A
that's
little too much
a little
tilt.
too back. So that's going to impact your penetration, especially with reflective metals.
All right, so let me show this to the camera here. Even though we bent this one part up, you can see the work of an expert.
Pull it away a little bit. So yours is the one on the left.
Yeah, the hot one. So you can see. So you can see
Yeah.
his weld and my weld. Mine's kind of beady and a little irregular, but the alignment is pretty good.
And your first.
And I don't know if I got good penetration. I think he got better penetration.
Well, there's only one way to find out, sir.
Well,
That
seems
was
decent.
one way.
All right. Let's take a look here. So you got less penetration. And okay, here's a good teachable moment here.
Oh, good.
So you can tell when you're moving a little fast,
Yeah.
when you can actually see the wobble pattern in the bead.
Oh, yeah. I don't know if you can show that up, but point to that like very, very carefully.
So you can actually see the wobble pattern
Keep it there. Okay, got it.
within the bead. That's how you know you're just going a little too fast.
Got it.
So had I slowed down, I would have, that wobble pattern would have disappeared.
Correct.
Penetration would have been a little bit better. And
And
would the bead still have been as prominent or less?
So the bead and the penetration were more of a tool angle thing than a
Okay.
speed thing. Because I don't know if you were, your travel speed was quite a bit slower than mine.
Yeah.
But it was because that laser was fighting to get penetration just dancing over the surface
Got it.
rather than actually getting fired in there.
So I thought I was going slower, but in fact,
You were.
it was the angle that was the reason I didn't
Correct.
get the penetration.
Correct.
Okay. Though, I would think, like, all right, let's see.
I'll let you do the honors.
Well, we should do it consistently. But
Wait. If you're gonna do the honors, let me make sure I get it.
All right. It's mean if I hit yours.
4.
You're good.
All right, here goes. Harder? All right, let's get real. Yep, not good. Not so good. Yeah, I probably only penetrated like halfway through here. So I did better on the stainless, but I can see this would not be that difficult to get good at.
It doesn't
Angle, settings.
Yep, angle settings, travel speed. It's still a tactile process, but after you spend enough hours on this machine, you'll be able to do it by sound.
Yeah.
You can actually hear what's good fusion.
Yeah, another thing I noticed when I was doing the aluminum is I didn't have that same sort of tactile feel that it was trying to push me because there's no wire.
There's no wire.
So I've just got to really
Yeah.
base it, like you said, on sound and experience.
Correct, and to be fair, even when you're doing wire assist with aluminum, just because that filler is so soft,
Oh,
you have to have like a safe cracker's hand.
yeah, okay, which I do not.
Yeah. Well, you come back for 2 more days,
Yeah.
and I could get you there.
And I could practice it.
Yeah, yeah.
Okay. Now, can you use this, for example, to repair a weld? Like, say I did this, where you saw before I split this apart.
Right.
That it didn't have good penetration. Could you go around and repair this without added wire or anything else? Just turn it around and melt the inside, or is that kind of...
So you got to think about what sort of damage that existing heat input made. If you already made a hole, then you're not going to fix that with a fusion weld. Yeah.
Okay.
But that being said, I mean, I have had some people use this for what they termed laser cladding, laser brazing, and if it works for you, then it works for you.
Okay.
You can do repair jobs with this as long as you're willing to accept that you're restricted to a 4 mm wobble width. That's
Yeah.
the widest bead you can do.
Right.
And if you're looking for build-up work, it's going to take you
Take a low.
quite a bit of time, but
Right.
it is possible.
Okay. All right. Cutting. Do you ever cut with this? Like say-
Absolutely not.
Okay.
Absolutely not. And nobody should ever, okay? Because it's a handheld tool. And let's compare this to a plasma torch. When you
Okay.
have a handheld plasma torch, generally you have a water trough or something to blow that into.
Yeah.
Laser companies, especially something off Alibaba or whatever, where they get the 3-in-1 machines.
Yeah.
Most reputable photonics companies, you won't see the handheld laser cutting, because again, you shoot a high power beam, you ain't stopping it.
Right.
So let's say, okay, if I was just going to hypothetically, and God knows I'm not going to do it, but if I was going to cut through that guide plate,
Right.
I would have my laser safety glasses on, try to pick an angle here, and I'll pretend to be lefty, okay? So I'll be holding my part, have my laser cutters on. Every bit of light that did its job well enough.
Is someplace else now.
Yeah.
Yeah.
Yeah. And it's a
Okay.
class 4 beam, so it's
Got
not
it.
just hot plasma that could hurt somebody's skin. That class 4 beam could retire somebody.
Got it. Okay. Now, how fast does this beam spread, roughly? Like, say, at the distance of the floor, are we talking a quarter of an inch, a foot, half a meter? What are we talking about? Like how?
So
much
it's
of a-
kind of hard to say, but
Okay.
imagine that guide beam. So
About a centimeter or two.
there's the workpiece. Now this is actually not. Let's do this. Here's an even better way. I'm going to take the interlock clamp off.
Okay.
Okay, so now that should. Yep, that's just the solid dot.
Yeah.
So judge for yourself. You know, you can still kind of see it.
Yeah, so I would say even if the camera doesn't show it, it's probably about a centimeter and a half, about a meter away. So it's going to take a long time before that won't hurt somebody.
Yeah, yeah. Well, it's many yards.
Yeah.
That's why you don't do this outside.
Okay, that makes sense. Now, aluminum, stainless steel, galvanized, can you do galvanized steel or is that?
We can do galvanized steel. It depends on the blend.
Oh,
That's the best way I can put it to you. So I've had some galvanized, like I'll give you a few examples here. All right. This will kill a laser tool nearly 100% of the time.
why will it hurt the tool? Just because of all the zinc that's coming off? Or?
Zinc and the fact that it's flaked like this, it's not so much just that it's reflective, it's refractive.
Oh, okay.
So it's
we
going
need to
all the way.
refocus it and change the whole,
Yeah.
all the rules.
So not only does it stink and it gives off a lot of zinc powder, I mean, this is actually, now this was just some dev work, so this was with some S2 wire. That's not my prettiest, that was just me dialing stuff in. There's still a lot of zinc powder down there.
Yeah.
So even when you can melt it, I generally don't do it in front of other people when I'm in here, just because it will gas this lab out.
Yeah.
And not only do I have that extractor out, I'm also wearing an LPR all the time.
Okay.
But can it be done? Yes, use S2 wire, 70 S2, that's what you want.
Cool. Now, what is the sort of maintenance interval on this, other than replacing the nitrogen or the argon and the wire, which we consume? Would this thing be able to run sort of almost indefinitely until something goes wrong, or is it like once every 20 hours it needs to have some sort of refurbishment? Or?
So, good rule of thumb, if you're gonna be integrating this into all day, everyday production, all right? The beginning of every shift and coming back from meal period. Take a look at this. Now, I can do this in my lab because it's clean, but ideally you'd put a piece of masking tape over here, pull out this protective window. That is what's keeping your optics safe. That's just an infrared coated,
Camera.
Yeah.
it's just an infrared coated piece of glass.
Keep it there for a second.
All right, yeah, I can't really tip it, otherwise it might take
No,
a
it's
tumble.
fine.
Oh, it's loose in there, it's just
Yeah.
sitting.
Just give me a second.
Yeah.
So that's just a piece of quartz or optical glass that's got a coating that will effectively allow the infrared through.
Correct.
And an
correct.
aiming beam at about 650.
Right. So you have that one, that any operator should be able to do that. There's a second one behind this in a screwed in door in case this one does get shot. After that, it's a matter of taking the machine down and breaking down the torch.
Okay.
Generally, when we're talking about the focus lens or the galvo getting damaged, it's not a regular consumable. That's either from lack of training or somebody using this as a slag hammer or any number of other human errors, operator errors. But with that said, I actually held on to a couple. You just mentioned galv.
Yeah.
This is what can happen very quickly to a protective window when you're trying to weld the wrong alloy. So that's actually a very small hole
Can
made
you
by,
bring it closer?
yeah. I can just hand it to you if you want, man.
I know, I can see it.
Okay.
Yeah.
So that's the galvo mirror, actually? Or is that the window in front of the galvo mirror or behind the galvo mirror?
No, this is actually a, this is the protective lens.
Okay.
This is a laser strike back reflection off galvanized steel.
Okay, and that is actually a window, that's not a lens?
Correct.
Okay.
Yeah, it's a flat window.
Okay.
Yeah. But I could, this is your main consumable, is
Yeah.
these. They're $6 a piece. All right.
So you have more than one available?
Yeah, I would recommend anybody who wants to buy one of these units, just get a sleeve of 20.
Okay.
And you should be able to get yourself good and consistent in the time it takes you to go through that sleeve.
And then you don't need so many?
Right. Now, that being said, that was a pretty extreme example of a damaged protective window.
Yeah.
But now, this thing, I've passed this around to plenty of students. So there's a whole bunch of hand grease on there. Let's see if I can do something about that.
This is,
And that's
this
how
is,
you clean.
exactly, I was gonna say, this is an optically clean shirt.
Yeah. But to be fair, you can see just the slightest hint of the laser strike in that too.
Oh, yeah.
Yeah, but you really have to
But
look
you're
at
really
it.
almost like at a bleak angle and the right lighting and
Yeah.
But
But
that's
you're-
enough to be considered damage.
Yeah, that's enough to, well, not only will it be considered damage, if this thing gets opaque enough or damaged enough, it'll just start ramping you down as soon as you fire the beam. You won't be able to weld.
Oh, so the laser is actually detecting that back reflection and
Correct.
it gets to a certain level. It's
Correct.
like, oh, okay.
So there's back reflection detection,
Right.
there's plasma detection, and there's also a protective lens thermostat in there. So,
Okay.
so if it starts getting too hot, our machine actually has a built-in feature that will brick the machine for you and will tell you, we're not going to let you fire this anymore until you call up customer service and we figure out why you're making this lens this hot.
Ah, okay.
And I know Ryan loves that feature, even if he didn't tell you about that, but that will protect so many new users from
Yeah.
downtime
It's the new
unnecessary.
users, especially with the technology that, even though you've been doing this for 4 years, there aren't very many people who have done it longer, right?
Mm-hmm. Correct.
So it's not like you've got 40-year-old guys that curmudgeons that come in there and say, nah, you know, that's.
Right, yeah.
You have to have the ability initially to expect that you're gonna have user failures.
Right. Listen, and this goes against a lot of marketing for handheld laser welders, but I was a structural welder for 8 years before I ever touched a laser tool. When I was recruited by my original laser manufacturer employer, I took a look at this thing and I said, this is okay because it doesn't completely de-skill welding.
Right.
Okay, in fact, I would say you have to have quite a good degree of intelligence approaching a class 4 laser tool that could blind you permanently right off the bat.
Right.
That being said, if you can get your facility and your part diameters and your operators in line with this tool, there's no reason not to explore it. I'm not trying to make anyone poorer. It's another tool for the trade belt.
Right. Cool. Well, thank you very much. I really
My pleasure,
appreciate it.
my
This is
pleasure.
a good education.
Come back, and I want to see you. I want to see you do I want to see you do a good outside corner next time.
So when you have customers that say have a lot of welding experience or a welding company and they're considering getting into fiber laser welding, what are their major concerns and how do you address them?
I think the number one concern we have seen on the market is about, is laser welding safe?
Okay.
We have addressed it with a lot of laser safety trainings. We have the safest laser welding equipment on the market. So yes, laser welding is safe as long as you take care. That's the first concern, the laser safety. And the second one is laser welding as good and strong as the traditional welding technology?
Okay.
And we have proven that with our applications lab in our academy, where our customers can send in samples and we can weld them, or they can weld them by themselves and test it and prove that it is.
And they have, and it is.
They have, and yes, it is. It has always proven that it is.
And less heat affected zone.
Absolutely. With less heat affected zone, with faster, less consumables, easier to use, all the laser advantages.
And how about the initial investment in the system that I used when I was in the laboratory compared to a typical full setup with the wire feeders and a typical Lincoln Labs type of, MIG welder or something like that? Is it comparable in terms of cost?
Of course, I cannot talk about the traditional welding system cost. I can talk about the laser welder, but what we have got feedback from our customers is that it's comparable. It's the initial investment, it's more or less comparable. And
No sticker shock.
no, absolutely
Okay.
not. We have a comparable equipment cost, not on equipment but all in the infrastructure. And once you have that, the welding cost is way lower. It pays back very fast.
Well, I've got to get one of these, at least one. I really appreciate your spending the time and making arrangements for us to be intrusive with all the filming, but this has been eye-opening and really a lot of fun. This was a good trip. I don't know where you're going from here, but I would love the opportunity to maybe at some point in the future come back and see how things are moving along.
Eric, we would love to see you here again soon, seeing our new launches. We will surprise you. We have quite a lot of surprises to come soon onto the market.
You're going to keep that under the...
I am not going to tell you about that right now. I prefer
Okay.
you to come soon and see and test our new launches that are coming very soon.
Fantastic. Well, I want to say thank you very much. I really appreciate you spending the time.
Thank you so much for coming.
Okay.
And our doors are open for you to come back again.
Very good. Okay, well, take care.
Thanks, Ben.
So, even though they probably wouldn't agree, I now feel like a laser welder. This was amazingly easy. It was a little bit disorienting when you first start out because it's a whole new way of approaching welding. But just the fact that without ever having done it before, only saw 15 minutes of videos before I went into the laboratory, and I thought I'd made some pretty decent initial attempts at doing welding. And I could imagine after an hour or two, you'd be doing some pretty good work. So fiber lasers and the ability to integrate that with a very, very large market of welding It isn't necessarily a disruptor to the market because it does have applications that are going to be most appropriate for that type of energy deposition and some of the features that are available with light as the heat source. But I can imagine that as this becomes more and more popular, there's going to be more and more applications where you can cross over. And eventually there's going to be new products out of companies like Theo that are probably going to push the competition, which pushes development. And the greater the development, the greater the access to technology for all the rest of us. So I had a ball here, and we are undoubtedly going to be returning in the not so distant future in order to explore some of the new products, new evolution of their existing products, and we'll learn a little bit more about what you can do with fiber lasers. So back to the lab, and I thank you very much for watching. And if you like what we did here and you want to see more of these visits to remote sites and visiting corporate facilities like this, put it in the comment section because I read all the comments. I try to respond to as many questions as possible. And if you like the channel and the kind of programming that we're doing, please consider subscribing. It really helps with the YouTube algorithms. In any case, we've got a long drive ahead of us, so I'm going to get going. But thanks for watching. Take care, and we'll see you soon.